Hi everyone, I'm Giorgos. We'll talk today about measuring web performance with user-centric metrics. A few things about me at first. My surname is quite long, it's Bamparopoulos. I'm based in exotic Manchester. I work as a senior software engineer at Bet365. And I'm working mainly with TypeScript and JavaScript on the front end and .NET on the backend side. You can find me on the social media links here. I am also the organizer of the Manchester Node.js Meetup. We have scheduled a series of virtual meetups from this month. And if you're interested, you can join the next one. It will be on the 25th of May. And we'll talk about serverless JavaScript, what you can do with Lambda, AWS in 2021, and about doing contact tracing, one of the COVID apps with JavaScript. So what is performance? We have to define what does it mean to developers, to us. What does performance means to the users, to the businesses? Is it important? What is the user experience? How do we measure user experience? And what we can do with all this data? But first, let's see if it's worth the hassle, if we need to bother about measuring and analyzing the performance of our web applications. Here you can see some statistics. 53% of mobile site visits were abandoned if a page took longer than 3 seconds to load. The sites loading within 5 seconds had 70% longer sessions, 35% lower bounce rates, and 25% higher ad viewability than sites taking nearly 4 times longer at 19 seconds, which is quite a lot for a page load. Also, Pinterest managed to increase search engine traffic and signups by 15% when they reduced perceived wait times by 40%. I'm sure you can find many more statistics online, but as you can see, performance on web application doesn't really matter. And I put on the slide an impact calculator tool made from Google, where you can go there, you can put your website, and then it will scan your website with various tools, and it will let you know about the impact of performance. And you can correlate that with some business metrics as well. It's quite a nice tool. So we will start by defining what performance is not, and we're gonna help these guys bust some myths around performance that many developers might have. So the first myth is that the user performance can be measured with a single number. So in reality, performance of the website is not a single number. You can say, for example, that your performance of the website is a 70%, or even a page load. You can't really tell that your website loads in 5 seconds, because actually you have to see the bigger picture. There are many more metrics around that measure performance. Site speed is not as simple as having a single score, as we said, and we need to look at the entire user experience. There are many metrics that affect the site's performance. And even for a single metric, let's say that we want to measure the page load, it's not actually a number, but it's a distribution, because there are many users out there. Each one is experiencing different page load times. And if you construct a graph, you can see here like a distribution. This is a collection of all the page loads of all the users. And as you can see, this is taken from a website. The majority of the users experience load times below 4 and 5 seconds. But there are still users that are experiencing load times up to 10 seconds in there. And this is what we call a long tail in statistics. The second performance myth is about that performance and user experience can be captured with a single user. Now, as we do user research, for example, when you do A/B testing on the website to figure out what you want to do in terms of design, or you conduct an experiment, what you are looking for basically is at least a representative sample of users, if not all of the users. So if you measure performance with one user, which is usually us developers when we are doing the work, the results are not going to be very accurate. And why is that? Because, of course, there are many different conditions out there that we need to take into account. The user experience and performance is depending on many factors, depends on network conditions. Is the user browsing your application or your website through a fiber broadband or a fast broadband or even Starlink, or they're using a mobile phone and they have a bad 3G connection. Connection speed, device and hardware, again, they can use their expensive high-end gaming PC or an expensive phone, or they can use a lower tier phone to browse. All things matter because there's less memory, the hardware is not as good. Browser conditions and caching. Have they visited your application before? Is there any browser cache that they have installed, or do they use a fast browser, a modern browser, or they use Internet Explorer 7 or below, which I'm sure there are some users still using some old browsers. So all these things really matter when measuring. The last myth that we are going to talk about is that you only need to care about performance at load time. This is the first thing that comes to mind to most minds, at least, when we are talking about web performance. I totally agree that this is one of the most important metrics to measure, but it's not the only one, because actually performance is an entire experience. The user journey on your website starts when they hit that URL bar and they go to your website, and ends when they leave your application. And bad user experience can happen at any time during this journey. They can happen during clicks, when toggling form controls, or when the user presses tabs. If you have some JavaScript, for example, in the background, this might hold the event listeners, which will result in a poor user experience. It can happen when the user tries to scroll, or when the animations of your website feel a bit laggy and they don't follow the 60 frames per second rule, let's say. And this brings us to Rail model, which is a performance model developed that breaks down the user experience into 4 key actions. And these actions are response, animation, idle, and load. I won't go into much detail to each one of them, but roughly for response, the aim is to process events in under 50 milliseconds. So the end goal here is to have something back to the user in 100 milliseconds. And imagine you had some JavaScript running before. We usually want to avoid large tasks, long tasks that take 50 milliseconds. And this JavaScript has only started, and then the user interacts with the browser. This means that the event will go into the event queue, and it will be processed after 50 milliseconds, which means that if your event handler runs under 50 milliseconds, then you are fine. This means that the user will actually see something in 100 milliseconds. And research has shown that after 100 milliseconds, it starts feeling a bit laggy, depending on the user, of course. The second one is about animations. The guideline here is to produce a frame in under 10 milliseconds. This is based on the fact that most apps want to have 60 frames per second, especially when you have animations on site, which means that if you divide it 1,000 milliseconds with 60, then it becomes 16 milliseconds per frame. We give these 6 milliseconds to the browser in order for the paint and the instrumentation to paint actually the pixels on screen, which means that our JavaScript should aim to be run in under 10 milliseconds. Then it's about idle. The goal here is to maximize idle time as much as possible. This is for obvious reasons, because when the app is idle, this means that it listens for user events, and then it can respond quicker to user events. Some work that we want, and it's heavy in JavaScript, we can use here, for example, web workers if we want to do intensive computations, or defer some work that is not needed to be done later in chunks that are under 50 milliseconds. And the last one is load. The goal here is more broad, is to become interactive in under 5 seconds. Now, interactivity is kind of an underestimated concept. It doesn't mean page load time. It means that the whole page has been loaded and all the JavaScript has run, so the users can now freely interact with your website. So it's a bit different than page load. So now that we talked a bit about performance and what performance is not basically, we need to test it. There are two ways of testing performance. One is called the developer testing or synthetic testing or user testing, and the other one is the real world testing with real users. Now, both of these approaches have their advantages and disadvantages. For example, when we developers doing the performance testing, obviously we are on our own machine, we are during development, so it's easier to debug and develop and to do that iteratively. We use always the same environment, so we're comparing apples to apples really, from one release to another. But the drawbacks are that it doesn't really capture the real world traffic. As we saw earlier in the slide, there are many different conditions that the user can have when they visit your application, so it doesn't really capture that. And another reason is that we don't really have much benchmarking. If, for example, someone or some competitive sites of your business have posted their performance results online, unless you go there and manually test it with your own machine, it's kind of difficult to compare with one another. From the other hand, on the real world, the plus is that we get the real world user experience, so we capture all that information. We can also correlate that to the business KPIs. For example, let's say you have Google Analytics or any analytics engine, and you measure some things about your users, your bounce rates, your session times, and things like that. For the same users, you can correlate that with the performance metrics and the overall experience that they have on your website, and you can draw some useful conclusions basically based on that. The disadvantages is that it's harder to debug. Even if you are using the most sophisticated state managers in order to reflow and try to replicate the user session, sometimes it's hard to actually replicate the exact scenarios and exact conditions at that moment in order to analyze it. And the analysis, of course, that's another layer of analysis because it doesn't happen during development time. It happens after, which means if you find a performance bottleneck in there, a performance problem, you need to analyze it and then go back and fix it. So in this presentation, we will focus on the user side, which is called Real User Monitoring, or RAM. And it really consists of these 5 stages. Data capture, which means we need some kind of mechanism to capture all these metrics, all these performance metrics from the user browsers. Then data storage. All of this data, we need to store them somewhere for later use. Then it's the reporting. We have visualization. You can use visualization libraries or third-party tools like Google Analytics or Elastic to do this reporting, analyze the data, and then at the end, if you manage to convince the business, there comes the optimization stage, where you go back, optimize, and then start again. Data capture, data storage, reporting, analysis, and optimization all over it again after every release or when you find problems. So what is really user experience? What users think when they browse your website? And more importantly, how do they perceive performance? These 4 questions below will help us define some metrics about web performance. The first one is it happening? Which means, did the navigation start already? Is there an indication on the screen? Then, is it useful? Which means, have the most important content rendered yet on the web page? Is the user able to consume some information at this point? Is it usable? Which means, can the user interact with the content? And lastly, is it delightful? Is it consistent? Is the overall experience good after the page load? And these questions can help one define the following metrics. For example, first paint. This is happening when the first elements of the web page are rendered. First contentful paint. More elements are rendered on the page. For example, we have some text and some images that are starting appearing when the page loads. The first meaningful paint is about the most important elements of a page. Let's say, for example, you are working on YouTube. The most important element of a video page is the actual video, or a placeholder, at least, for the video. So if this is rendered, then you say that the first meaningful paint is that. Then time to interactive. This is the time when the user can actually interact with the page. And as I said before, during the Rail model, this is kind of different at page load, because this is the point where the user actually can click and receive a response. Because we've seen many websites, for example, I'm sure you experienced, when you load the website, you can see most of the things in there, but you can't interact. You click something and nothing happens. And finally, the long tasks. These are JavaScript tasks that block the main thread. And by convention, we say that a task is long if it takes more than 50 seconds to load. And in order to map those metrics to the questions, is it happening? That's your first paint. This is the first indication that something is happening on the screen. Is it useful? This is your first contentful paint and first meaningful paint. More elements on the screen. Users are able to consume information. Is it usable? Time to interactive. The user can finally interact with the page. Is it delightful? This comes down to the long tasks. How many JavaScript work is blocking the main thread? You can see the difference about actual performance, page load performance, and user perceived performance in these 2 slides. I have these page apps that are loading in those 2 slides, but they are loading at the same time, but quite differently. So let's say this application takes about 5 seconds to load. And up to the 4th second, you can see a blank screen. Nothing happens on the screen. And then at the 5th second, boom, you get the whole page. There and interactive, you can do whatever you want with it. So many users could abandon the site even before it loads at this point, because they don't even know if something is broken or if their browser or connection is stuck or something. Now compare that to this slide here. Again, the page loads at 5 seconds, but this time you can see on the 2nd frame, you got the first paint. You can see something on screen. So you're saying something is happening, it's definitely not broken, and continue. On the 3rd and 4th frames, you can see some more. On the 3rd, you can see an image, and on the 4th, you can see some content. Now, from this point onwards, you can already consume information. You can't click, probably, because things are blocking the main thread, but at least you can read something, and you can see something on the screen. And finally, at the last frame, you've got the time to interactive, which means the application now, the website is fully responsive, and the users can interact with it. And as you can see, this results in a far greater experience compared to this one. And it's all perceived performance, right? Because the application has loaded exactly, took exactly the same amount of time to load. One thing that definitely helps with at least the first meaningful paint is to identify what's your most important element of your website. And then you can target this element to be rendered on screen as fast as possible. And this will add to the perceived performance for the users. So I gathered here 3 websites. The first is the meetup.com, second one is YouTube, third one is Airbnb. And I believe that the most important elements are these ones. So on the Meetup, you've got the Meetup description and the Meetup photo. On YouTube, you have the video or the video placeholder, if you can't load the whole video, the thumbnail, basically. And for Airbnb is the form. So once you are identifying those elements, then you can track them using the metrics and mechanisms that I will describe in some slides. Also, there are other performance metrics. They are not new, they are relatively new, and they track different stuff. For example, large contentful paint, it tracks the largest elements instead of the most important element on the screen. The total blocking time, it quantifies how strange the main thread is. And it basically what it does, it's like a sum of all your long tasks, which are the tasks that take more than 50 milliseconds to load. And lastly is a cumulative layout shift. This is a fancy name, and it basically means that I'm sure you've seen websites, when you load websites, things are going up and down or right and left before they get in place. And this is like a metric that calculates the percent of the viewport that is moving. So now that we talked about the metrics, how we can measure all that? It would be good to have some kind of tools that we can use to measure. How did we used to do that? Well, I used to do that with request animation frame. So you can have a request animation frame and measure the time that took from one frame to another. If you have animation intensive applications, that's definitely one way of doing it. Also, usually developers need to measure the time between 2 points in the application. For example, you have a function and you want to see how much time does the function take to finish. So you start the daytime before and the daytime after, you subtract that, and then you measure it. But these are not very helpful, and you can't do many things with this tool, to be honest. And fortunately, there are other web APIs, and there are W3C recommendations that really help us with that. So these APIs are the performance timeline, user timing API, navigation timing, and resource timing. So these APIs are used by the very same tools that you can use to measure performance, like the Google developer tools, for example, Google Lighthouse, Web Page Test. They all use the same tools. They have good browser support, but it's always good to check, because if you support some legacy browsers, then you might want to check and see if your browser is supported. So now let's get into more detail about these APIs. The most basic concept is a performance entry. The performance entry is a single performance metric that is part of the performance timeline. This entry is actually a timestamp or a collection of timestamps that can give information about different types. For example, they can give information about the page navigation, about your page resources like image scripts, CSS, videos, iframes, and all things. Information about paint. This is about the first contentful paint and first meaningful paint that I was talking before. Information about long tasks. And you can also define custom application entries. For example, I was telling you before, when you want to measure 2 points in the application, you can have your own entries, add them in the performance timeline, and then store them somewhere. So these entries have 4 properties: the name, then the type, which is one of the above bullets, a start time, and a duration. So once we have the performance and we add the performance entries in the performance timeline, then we can use the API of the timeline to get the entries back, or to enter the entries, to get the entries for navigation of the resources. We have three methods here. Performance.getEntries, this gets all the entries from the timeline. Then performance.getEntries by type, we specify a type like navigation, resource, a mark, and we'll get only the entries of this type. And lastly, the getEntries by name and type, we specify a custom name, for example, my entry, and the type, for example, mark, and then we get only this. So let's talk about the application entries first, which are the easy ones because we tend to do it already. As I said before, we might use the date object to do that. So here you have a mark, which is a performance entry that's created by the application. It's actually a timestamp. And then you've got a measure, which is really an entry between 2 marks that you can measure. How you can do that? Performance.mark, in here, we give it a name, mark1, and then we have a long task. We call a method. And let's say we want to measure how much time does this method run. After the method, we set up another mark, performance.mark. We give a name, mark2. And finally, we define a measure, performance.measure. We give it a name, measure1. And then the 2 marks that we want, mark1 and mark2. This and all this, they added the 2 marks and the measure on the performance timeline. How we get them? Again, we use a performance object, performance.getEntries by type. We pass in the measure as a type, and we get the first result. And you can see there, we console log the duration. We said that every entry has a duration and a start time stamp. And you can see there that it's actually 5,000 milliseconds, which is what we expected. Because the long task, you actually pass it the amount of milliseconds that you want to pause. The second type is about the navigation entries. And this is when the page loads, we get all these timestamps about the different stages of the navigation. It actually breaks down the events that are required to retrieve and display the web pages and provide timestamps to each one of them. But what really happens when someone is browsing your website? How we can break down the navigation? It looks like this. It might seem a bit of complicated, but every time navigation starts, it has to pass through all these stages on the blue and yellow boxes as you can see below. So you have your unload events from the previous page, then you have your redirects, the upcast, DNS connection, TCP, the request starts, then you get your response, and then you have your styles and DOM processing, and eventually the page loads. Now, for each one of these stages, you can see all these properties around here on black and orange. All these properties actually are timestamps during this timeline. For example, when you do the request, you have this orange here, request start, and then you've got, when the response starts, you've got the response start timestamp in here. And all these timestamps are available on the navigation entry. And let's see how we can get those. These are being handled automatically by the browsers. So the only thing that we need to do is to get them. How we can do that? Again, performance.getEntries by type. We specify navigation as a type, and we get the first result. And if you console log that object, you get something like this. You can see the name. That's a page in the meetup.com. And duration, you can see it's around 6 seconds, which is the page load, basically. And actually, the object it's really big. This is only a part of the object. You can see at the very end, fetch start and domain lookup start, they were out at about 2 seconds. And the same you will get about all the other timestamps, like the DOM content, when the DOM was parsed, and all things like that. Based on this navigation metrics now, you can calculate many different metrics and many different properties. For example, again, we get performance.getEntries by type, we get the navigation. Let's say now you want to calculate the request plus the response time, but network only, without taking account any cache. You could do that by subtracting navigation.request start from response end, and this will give you the response time. If you want to get the response time only, the download basically, what you can do is you can subtract the response start from the response end. And if you want to get the time to first byte, which is basically when the request starts up to the time that you get the first byte of response from the server, you could do that by subtracting request start from the response start. You can calculate many different properties. It's up to you and your specific requirements. My advice would be to store the raw results on the server, basically all the navigation entry. You can use a NoSQL database easily for that, store them in there. So if you change your mind and you want to calculate some metrics differently, or you want to calculate more metrics, you can do that with all the data that you had already, instead of trying to get new data from the users. That was it really about the navigation metrics. But what about single page applications? As you might know, in the single page application, you have one request, one page load at the beginning, but all the subsequent page loads, they are not actually loads in the traditional concept, but we mainly lazy loading JavaScript and other resources, CSS and images and all this kind of stuff, like to kind of fake the navigation. So this is a bit of a hard problem, really, because at first we have to define what is navigation, what navigation means to your application. For example, do you consider that the navigation has ended when all the JavaScript has been loaded, or all your components, or all your requests and data come through? So once you define that, and thankfully the majority of the frameworks out there, they have some lifecycle hooks that you can use. Let's say that you have a hook that is fired when your top level component for the new route has fired. What you could do is you can set up some custom performance marks, as I showed before, and when the navigation starts and when the lifecycle hooks fires or finishes, and then you can store these custom results on your backend and consider that it's a navigation apart from the page load. Let's move to the resource entries now. We talked about navigation, we talked about the custom performance metrics. The resource entries is all the information that we have about the JavaScript, CSS, videos, fonts, all the resources basically that we have on a website. It uses the concept of navigation. Most of the stages of the navigation are the same with the resource entries, apart from the DOM parsing and page load. The resource entries also, they include the transfer size and the body size of the request, both encoded and decoded. And you can draw a waterfall of all the resources that are fetched from the network in a really nice timeline. I'm sure most of you will be familiar with something like this that you can see on the network tab, for example, in the Google Developer Tools. In here on the left, you can see the resource names and the types. They are all scripts, basically, the initiator, and the sizes, the times, and then on the right-hand side, you can see the waterfall. You can construct this yourself using the APIs, the very same APIs that we saw before. Now, the resources are a bit different than the page load, because not all the resources are being loaded on the first page load. You might, for example, lazy load some JavaScript or some images or some CSS later on, which means what we need is some kind of mechanism that will let us know every time a new resource is downloaded to the browser, it fires a method so we can get all these performance results. And we can do that with a performance observer. A performance observer obviously is using the observer pattern, subscribes to performance events, and you can provide a callback that gets notified when new edits are added to the browser performance timeline. And you can later then respond to this performance event asynchronously. So you can gather all these events and then send it to your server. This has three methods: performance.observe, which is start after you created an observer, it starts observing. Disconnect, you disconnect from the, you no longer receive events from the performance observer. And performance.take records, which means that you take all the new entries and then you erase the list. Let's see one example. So in here, we define a performance observer, and we create a new object, and we pass in a callback. The callback gets the list of the new performance entries that we're going to get, and then observer. So, and at the very end, you see we subscribe, and we specify the resource as the entry type. You can specify the entry type that you want. For example, a custom marker, resource, the paint, whatever you want. So once this callback runs, we have access to the list, to the new entries. So we can list the list.getEntries method to get all these entries, and then we loop for each one of them and console leg. And we get something like this. So each one of those, they are resources. You can see initiator type is linked, so it's probably a CSS resource. And you can see all this information. You can't really see it from the screenshot, but all the timestamps are there. For example, connection start, connection end, the duration of the response, TCP connections, everything is there. One thing to keep in mind is about the cross-origin resources. Due to privacy protection and security reasons, you don't get all the timestamps available, all the metrics available in there. Basically, the only timestamps that you get is the start time, which equals the fetch start, the fetch start itself, the response end, and the duration. If you use a CDN that you can override some of the HTTP headers or add your own HTTP headers. Basically, you can override the behavior by sending this timing allow origin HTTP header, which means then that all your cross-origin resources will have all the timestamps available. Our next type is the paint entries. This is when the browser converts the rendered tree to pixels on the screen. These basically have only two metrics, the first paint and the first contentful paint. Again, how we can get it, performance.getEntries by type. We specify paint as the type. And then for each one of the entries, we console log the name and the start time. And as you can see, on the web page tested, the first paint took around 1,800 milliseconds, and the first contentful paint took about 50, 60 milliseconds more at 1,900 milliseconds. And that's really it. We haven't talked about all the types. We haven't talked about the long tasks, but you get the idea. For each one of these types, you can use the same API, the performance timeline with the get entries by type. You specify a type, and you get all your results. Now that we've seen how we can capture this data, what are the use cases? What we can do with that? Firstly, you can measure your page load. As we said before, one of the most important metrics. So it's really useful. You get the navigation entry and you push it to your server. You can send all these timestamps to your analytics provider or store it to the server for later use. You can also raise an event if any of the resources takes more than expected to download. Now, this is important for these elements that I was telling you about before, the most important elements on your screen. So let's say you have a big image that you want, or an iframe, or a video, or something that you definitely want to be on screen as fast as possible, and that might result in a better user experience. So what you can do is keep track of this performance resource on your server, and whenever you see that it takes more than expected and you have a threshold there, you can raise an event, send an email or a message or something to you, or raise an alert so you can have a look and fix it. You can also track specific resources. So most of the websites out there, they use third-party libraries. It either be a framework, or it might be ads or analytics, or any third-party resource really. So you can track these specific resources, and if you see that performance decreases at threatening levels, then you can let your third-party provider know, or fix it yourself, or change your provider or something like that. Because sometimes it's not us, but it's the code that we load on the website, the third-party code, that causes issues with performance. And finally, you can see your event listeners. How long did they take? And if you have a custom mark inside your event listener, for example, you can compare it with the event timestamp. And this way you can see how much time it took to fire, because you might have, and this is very hard to debug, if you have some long-lasting tasks on the background, JavaScript tasks, that's blocking the main thread, more than 50 milliseconds, this means that the event listeners might take long to fire. And when you're doing performance testing yourself as a developer, you usually browse the site differently than the actual user. So that's quite important. Now that we found our use cases, it's time to send the metrics to the server. The goal here is to gather as much data as we can from a single session from the users, and which means that we will need to leave it until to the last point, just before the user leaves the page. And this is the point that we want to send all the performance metrics for that user. Now, there is a problem with that, because browsers tend to ignore the asynchronous XML HTTP requests if you put them in the unload handler. And if you, instead of making an asynchronous request, if you start and make a synchronous request, this means that you're actually blocking the next page from rendering, which will result in a poor user experience. So what's the solution for that? Fortunately, Beacon API comes to the rescue. It's a W3C recommendation. It's a web API that actually schedules an asynchronous and non-blocking request to a web server, even if this request is initiated in unload handler. And basically, this request is guaranteed to be initiated before the next page loads. On the screenshot below, you can see an example. Let's say you have a method. It's called getUserPerformanceMetrics that does all these calculations, performance.getEntries, and populates all the entries into the metrics object. Then you can define a method sendMetrics that calls navigator.setBeacon. You pass it your application, your server endpoint, and the metrics, basically the object. And then you set up a event listener on the window on the unload event, and you attach your method in there. So this way, you have unblocking request, guaranteed to run. But I'm not sure, I don't think this is supported in all legacy browsers. Again, as with the other web APIs, it's good to first check, and maybe if tracking legacy browsers is not important to you, you can fall back to another method. So now that we gathered all the data, it's time for analysis. What we can do with analysis? We can draw some histograms and distribution with all these metrics and see how they affect users. We can compare users that are browsing through desktop or their mobile phones across different browsers. One other useful scenario is across different geographic locations, because not only users from different geographic locations can have different connection speeds, but it's actually, if you use a CDN, for example, for all your resources, you might find that your CDN, let's say in one part of the world is broken or is slower, and you can quickly see this kind of things if you have, if you capture user location. So if you have a custom solution, you can basically add all this additional user context along with the performance metrics. If you use something out of the box like Google Analytics, Elastic, or any other analytics provider in there, and you're already tracking the user location and all these browsers and stuff, then you can convert them easily in there. You can also draw some benchmarking, release by release, see what has been improved, and also correlate performance, which is one of the most important bits, with the business metrics. Because this is actually, the business is actually responsible for giving you the time to do all that, to investigate about performance, identify the performance bottlenecks, fixing them, and most of the time they can't really talk technical, but they can talk business. So if you correlate those with the business metrics, that will be ideal. Here I've added some tools that you can use for doing the performance testing. The first three, Waterfall, Perf Mod, and Performance Bookmarklet, they're actually browser bookmarks, and some of them they have browser extensions as well to use. And at this point, I'm going to show you how you can use some of them. Right. So let's say we are on the Meetup, Cambridge Meetup page. I have the bookmarks here. You can go to the GitHub page. There's a JavaScript code where you can copy and paste it and make it a bookmark, right? So I'm testing the first one, which is a waterfall. If I click on that, then you see here, I'm getting the resource timeline, basically. These are all the resources that the meetup.com site has loaded, and this is the timeline. This uses the performance timeline, as we saw, with a resource type. So they track information only about the resources. Let me load the page again. And now I'm going to use the second one, which is Perf Mod. So if I use that, you see here on the bottom, you get first paint, 1,600 milliseconds, and the page is fully loaded at 9 seconds. It took a bit more to load. And if you see some green boxes in there, what basically do is for every image, it tells you the duration on the time on the timestamp on the performance timeline, basically. So you can see 1,533, 534, and things like that. And yeah, and I think this color bar here means that some of the resources took more time to load than the green ones. Let me load it once again, and I'll show you the last. So the third one is a bit more sophisticated. It captures performance metrics from both resource and navigation metrics and some paint. So if I click that, you see you get all this window here, the number of requests. You get some metrics in here, time to first byte. We talked about that. DOM content loading, DOM processing. You get the slowest call and your average call. Here you got the navigation timing, which is all the navigation metrics. If you see DNS, TCP, your app caches, everything basically, your DOM interactive, and you have all your timeline here, up to onload event. This is the same as the slide that I showed you before about the navigation timing. You also have some requests by domain, by initiator type, by file type, JavaScript, images. You can see all the results here. How many requests, the percentage of your requests, and everything. And at the end, you get all the information about the resources as well, all the JavaScript, CSS, everything that has been loaded on site, along with the timeline and some useful information in here. So these three tools basically is most to have a quick look if you want on a website. Most of the things in here, you can do them through the Google Developer Tools or Firefox or whatever on the network tab. But it's useful if you want to investigate more on how to draw these timelines, how to do that. You can check their code on GitHub. It's quite useful. The other tool, Elastic APM RAM agent. I'm not sure if you guys are familiar with Elastic. I won't go into much detail, but Elastic is really a search and analytics engine. And in order to get that real user monitoring into there, we have to have installed three different standalone products. One is the Elastic, which is the search and analytics engine. The other one is the Kibana, which is, again, from Elastic, but a kind of visualization layer to visualize all this information. And you have this APM server, which is called Application Performance Monitoring Server, which is basically a server that gets all your results from the client, feeds those to Elastic, and then in turn Elastic feeds those to Kibana. So this is really intended if you already are using this stack. You can also use the stack in the cloud, so you don't have to install all of them. Personally, just to give you a quick walkthrough, I've installed them on my own computer, and we can see what kind of metrics we can see on Kibana. So I have these three services running. One is Elastic, the other one is Kibana, and the other one is APM server. And I had this basic code here. Can you see the code on my screen, basically? Okay, cool. So this is really a simple app. It's just an H1 with an image. So I have an image in there. And what I've done is I took this Elastic script, this Elastic agents, and I put it on my application, and I initialize it with just my service name and the server URL. This URL is the URL that you use for the APM server, which is possible to send the real user monitoring metrics to the Elastic. And this is it, really. The setup is just 2 lines. Set up just add the script to add the APM agent, and this script here to initialize it. So my application looks something like that, right? It's just a picture of a cat that I took online before. So when I load the page, the JavaScript agent gathers all these results for me, feeds them to the APM server to Kibana, and then I can see them from Kibana. So if I go to Kibana instance, this is what it looks like. And what you can do is you go here, observability, user experience. So if I click at user experience, you can see I get all these nice metrics and stars here. I get the page load, 800 milliseconds. Well, it's less because it's just one image. You have backend and front end here. First contentful page, again, 700 milliseconds. You get your total blocking time, which is quite a lot. All my long tasks. This was because I had some JavaScript in there that was looping up to 10,000 or something, just to mock some latency in there. You can see 4 long tasks I have. Long task duration 200 milliseconds. Large contentful paint, the most important elements to have on the screen, the largest elements that we have on the screen, cumulate shift, one of the new metrics that I told you before, and then you can see the distribution. This is what I meant, that the page load time is not a single number, but it's actually distribution. This is what you see in real life. Some users in here would experience good loading times. Some of the users around here, more poor results. The good thing about this visualization is that you can filter by geographic location, as I was showing you before in here. And you can also filter by browser, operation system, devices, anything really. And this is just the main dashboard. You can go further, and if you select APM, run test app, this is my application. So if I open my application, you can see the latencies here, and you can see the navigation, all these results, total blocking time, log tasks, and all things like that. You can see the latency distribution as well. One transaction took 700 milliseconds, one other transaction took double amount of time. You have all this data available on Kibana. And more, if you go to Discover and you search about the metrics that we were talking before in the presentation, for example, navigation, you can see all of those here. You see connect end, connect start, domain lookup start, DOM complete, fetch start. If I search for paint, I get first contentful paint first. If I click on that, you see top 5 values. I can visualize those. And this is my first contentful paint for all of the users, which, well, in this case, it's just me. So it's pretty, you can see only one bar in here, or basically 2 bars. But you can see, like, for every property, you can draw all these graphs. And this is completely transparent to you. You just have to add that JavaScript file into your front end, and that's it. But I have to warn you, you have to watch out about the performance implications when you're doing all this, because we want really to avoid the observer effect, which means when we're trying to measure the performance, we don't actually want to add performance overhead. So what you could do is measure performance before, maybe using custom JavaScript, then embrace one of these libraries, see how it goes. If that's acceptable to you, then you can use them. And last, it's Boomerang. I haven't played much with it. I just have it here for reference. If you don't use Elastic, it's a really good alternative to use, and it also supports the Beacon API for the asynchronous handling. Lastly, what comes next? After we identified what performance is, we measured performance, we send the result to the user, we visualize it, we did some analysis. Well, the goal is to always be faster. Release after release, we always want to be faster and faster, especially in data-intensive applications. How we can achieve that? It's good to test for both in lab, when we're in the office or at home, and in the real world, out in the wild. Both testing approaches, as we said, they have advantages. So we really need to test in both cases. We can also get notification if performance regresses. Here, as we said before, when we send all the data onto the server, we can have like a server-side application, for example, that watches all this, and we can specify some thresholds in there, and that can notify us with emails or something when something is wrong. What we can also do is we can integrate the performance test in our continuous integration. Lighthouse is a really good tool for that, Google Lighthouse. It's a Node.js library that we can use. For example, if you integrate that into your CI, you can even fail the build if the performance decreases. The advice in general from all people is start slowly if you want. You can have it as warnings at first on your CI. So wherever the performance decreases, start sending some warnings to key people or to the more senior members of the team. And as you are more confident, you can specify some thresholds and then fail the builds if the performance decreases. And that's really it for me. If you have any questions, please feel free to use the chat. I'm happy to answer them.
Great. Okay, thanks so much, Giorgos.
Thank you.
Just going to say, yeah, if anyone wants to, I'll just put in the chat there. If anyone wants to type in the chat, go ahead. If you'd rather do it like that, or you can use your microphone. You can just open up your mic. I guess I was going to start with one question around. You mentioned I was going to ask about the cost of instrumentation, basically. And have you ever seen real life situations where that's become a problem?
I think most of the libraries out there, they are designed with that in mind, because they are about to measure performance, and they are really designed with that in mind, which means most of them are being loaded asynchronously, and they have different optimization techniques that result in the least possible overhead.
Mm-hmm.
But I would say, if you don't need all of that, start simply. That's why my presentation was about how to do that instead of how to use the tools that do that. Because once you know how to do that, and you want, for example, to start with page load, you just need 2 lines of JavaScript. In order, one, to get the performance metrics, and then one, to send it to the server using the Beacon API. And then, as I said, once you're confident with that, if you want to test a library and get more sophisticated and more advanced features, then you can always compare before and after. I don't believe that they add much overhead, but they do add. They are like quite a bit lines of code in there. So I would say, like, if you don't need it, then you can start simple by doing it yourself.
Sure. Okay. I guess the other thing I was thinking when you were looking through the API, that performance API, was like you could end up with a lot of those kind of performance statements not littering, you know what I mean, like all over your code.
Yeah.
So are there any libraries to help with that in terms of making it nice and clean to the integration?
The integration for the rest of the code, when you're tracking metrics about your navigation and your JavaScript, CSS, and stuff resources, there are libraries that they can do that. As I said, like the API agent and the other library. But for the custom performance metrics, they wouldn't know. So this means that you need to set them up. It's like what you want to measure, really.
Yeah.
If you're using off-the-shelf frameworks like React and Angular, there are some libraries there that you can use. For example, for navigation, as I said, they can automatically go into your lifecycle hooks and send the metrics on your behalf. But again, if you want to go at a much custom level, like measuring some listeners or some functions, then you have to add them yourself. But it's really a line. And the good thing with the performance timeline is you don't need to calculate. You just specify one mark, and then you specify another mark.
Yeah.
And at the end, when you get the performance timeline, it's all in there. Whereas with the previous approach that we used to do, we were getting the first time, then we were getting the second time, and then we were getting the calculations and things like that. Whereas the performance is just like one line.
Yeah, that's nice. Okay, I'm going to open up. If anyone else has any questions, feel free to go. I haven't got anything in the chat. Okay, I think we may be letting you off here lightly.
Okay.
So
let me.
Sorry, I was trying to find my mute button. Sorry, almost got away. I had a question about the relationship between the sort of objective measures of performance and how that actually feels to the user. And I do apologize because I had to drop off for about 2 or 3 minutes, so I might have missed this bit. But so something I've noticed is a lot of the problems you mentioned were things like the page loading too slowly or not giving any feedback that it was loading at all, and people bail on the page before it's finished. And so a solution to that is to load as you go, to sort of load everything as soon as an image loads, stick it on the page. As soon as a heading loads, stick it on the page. But then that approach leads to the problem of things jumping around as things load at different times and your page shifts underneath you. And I wonder whether there's been any research that you're aware of that works out what the trade-off is in terms of, annoying your user with jumping content versus everything seeming to be slow.
I would say that when you have some things on screen being drawn, this doesn't necessarily mean that you have layout shifts. For example, most of the websites consist of a header, some sidebars, probably a placeholder. As I mentioned, for example, on YouTube, you have a placeholder in there. So these things, it's not hard to display to the screen and then behind the scenes load the rest of the JavaScript. You see what I mean? For example, you've got a video there. If you want, you can defer basically the rendering of the video until later, but you can have a thumbnail or a placeholder based on the viewport proportions and have it there so the layout doesn't shift. You can have your header. The header is pretty much static. Now you can have links can change, things can change, but it's one of the, I would say, well, depending on the site, but most of the sites that I'm aware of, the header and the sidebar, the widths and the heights are mostly there, and they don't really change much. So you can have like this kind of cell at the beginning, and your most important element, like just one element in the screen, and then load the other stuff behind the screen without shifting the layout. But because you have all this information available to you, it's easy to spot. So if you do something that's not ideal or there is a room of improvement, you will always know, because you will go into your analysis tool. As we saw in Kibana, you got both the layout shifts in there, you got your page load, your first meaningful pane, and all things. By comparing those, then I think you're gonna come into a nice conclusion of how you can fix them.